Hi there, this is Ms. Page. In this lesson, which is part of our Unit 3 on quadratic functions and transformations of quadratic functions, we are looking at what we refer to as vertex form of a quadratic function to identify the transformations for that function, which we'll graph as a parabola, and then apply those transformations to create a graph of the transformed function. So we've already learned about the parameters a, h, and k, and so we'll be identifying those and what transformations they create first in our function. We will be, of course, doing all of our comparisons to our parent function for the quadratic family, f of x equals x squared or y equals x squared. It is important that you learn how to recognize what we call vertex form, because if it's in another form, and there are other forms that we're going to learn about, one of which is standard form, you can't, those other forms, you can't identify all of the parameters. So you can't graph them using transformations. Vertex form, you can. So you have to realize you have vertex form or don't have vertex form when you're just asked to graph in general. So you know, okay, what are your options for strategies? So we know that our A parameter is going to tell us about whether we have an x-axis reflection, which would happen if A is negative, and the absolute value of A compared to 1 tells us we have a vertical stretch or a vertical compression. So if our absolute value of A is greater than 1, we have a vertical stretch, and the factor of that stretch is that absolute value, and if it's less than 1, then we have a vertical compression with that factor. Our H value, remember, we find by taking the opposite of what we find after the x inside our parentheses. And if h is positive, that means we're translating to the right. And if h is negative, we're translating to the left. And then k, which is found after the quantity squared. If k is positive, then we have a translation up. And if k is negative, then we have a translation down. So the parent function for our quadratic family, super important to realize the key points that you will be expected to transform. And you'll be expected, we have a total of 7 points here. You'll be expected to transform if they will all fit, or you can make them fit on your graph. And we'll talk about strategies for that as we go through some problems. But basically, the quadratic function is a fairly simple function. Y values are created by taking an x value, which is any real number, and squaring it. So what we do to create our key points that help us to graph the parent function is we use the integer values closest to 0 for x, and we use 0. So you can see we're going to use from -3 to +3, all of those integer values. And then we square each of those to get the corresponding y values, which are shown here, and that then creates our points. All right, so let's start this problem. It says to identify the transformation, so that means we have to clearly write all that information down, which we've done previously also. And then our second part we're adding to this is now to graph the quadratic function using the transformations we identify. So here is the function, the quadratic function we're going to graph. We recognize it's a quadratic function, remember, because x to the second power, or squared, is the highest power of x, and that is going to create a parabola, and we call that quadratic. So what we're looking at here is, given our vertex form, identifying our a, h, and k values. With this particular structure, notice that x, the squared, is right after the x. Hopefully you already realized this, but what is super important is to realize that what that means is that it was simplified from an x minus 0 quantity squared, because anything minus 0 is itself. X minus 0 quantity squared became x squared in the vertex form, which is a simplified format. So that means that our a value would be this -2. Since it's negative, that tells us we have an x-axis reflection. The absolute value of a would be the absolute value of -2, which is 2, and that is greater than 1. So that tells us that we would have a vertical stretch. And I'm just abbreviating here. I'm going to make a nice little summary of my conclusions in a little bit. The factor of my stretch would be the 2. Then I have to realize I'm technically taking the opposite of that minus 0 to get h, but the opposite of 0 is always 0. So our h value is 0, which means that we have no translation to the left or the right. And then we have our k value here, which is a positive 5. And that tells us that we're going to go up. So to complete part A, I'm going to make a bulleted list or write a little sentence listing what my transformations are. I'm going to do a bulleted list here. So I have an x-axis reflection. I have a vertical stretch. Whoops, need an R. By a factor of 2. And then I'm going to put my translation down. So I have a translation up 5 units because I only have the 1 this time. Don't really like that it's sideways, but I kind of ran out of room there. All right, so now let's go to the graphing. What is going to be super important is that you really start to consider what's going to happen to your points based on your translation, and also then that you realize, okay, well, what are my points? So remember that those x's, and I'm going to put them over here for reference, and I would recommend you kind of do the same thing, and these would be the y's, which come from squaring x. So the x's we use are those integers from -3 to +3. And then the y values that go with them are those numbers squared. Remember, when we square a number, it's always going to be positive. That's what creates our U shape for our parabola. So now realize that what an x-axis reflection is going to do is it's going to take all of your y values rather, and change their signs. So all of these y values here that are all positive are going to change to negative. So our positive 9s are going to become negative 9s. So that tells us we're going to need to draw our x-axis up near the top of our graph more than likely. However, we don't want to just jump in and draw it at the top because there's more going on. We have a vertical stretch by a factor of 2. That's also going to affect all of these y values. They're all going to double. They're all going to multiply by 2, which means our 9s are going to become 18s. We don't have 18 squares, I don't think, on this graph. 2, 4, 6, 8, 10, 12. We only have 15. So that means that the -3, 9 and the 3, 9, we're not going to be able to graph them on this graph. But all the other ones we should be able to, because 4 times 2 is 8, and we've got plenty of room to graph with 8 units with 15 squares. And then we also, though, remember, have this translation of going 5 up, which means that once these 4s reflect and stretch, they'll be at -8, but then they're going to move up 5, which means that we're going to take -8 and go to 5. And our 0s, which aren't affected by our reflection or our stretch, they are still going to go up 5 too. So this 0 right here is going to go up 5 to a value of 5. So I need at least 5 squares above my x-axis, and I might even want to make it like 6 squares just so I'm not at the top edge. Now I don't have any horizontal translation, so I should be fine with putting my y-axis right in the middle. Now I recommend that you put a few numbers to help your eyes make sure that you're graphing your points in the correct locations. Oops, okay, apparently I counted wrong, and that's going to be 5 at the top, but that'll still work. Notice I'm just putting my even numbers on here, just so it doesn't get too crowded with all of my writing. Okay, so now I am going to transform my parent points over here in blue. So 0, 0 is not affected by the stretch or the reflection, but it is affected by the translation that takes it up 5 units. So here's where my vertex of my parabola is going to be. And then because of the reflection, everything is going to go down from there. So now I'm going to take a look at 1, 1, which is right here. So 1, 1 is going to reflect, and then it's going to stretch to 2 units down, or you could stretch it first to 2 units above and then reflect it to 2 units below, and then it's going to move up 5 units. So we count up 5 squares, 1, 2, 3, 4, 5, and it ends up right there. I'm just going to get these points out of the way, my working points. Then we have -1, 1, and so it's going to stretch by a factor of 2, so it's now a total of 2 units. Remember, when we stretch, it's like multiplying our number 1 times 2. And we multiplied 0 times 2. That's still 0. And then we're adding that 5 after it. That's the math we're doing when we're moving our points around. So it's not an additional 2. It doesn't move up here. It moves right here. So now it's 2 total above. Then it reflects down. Then it counts up 5. 1, 2, 3, 4, 5. And it ends up right here. Notice how these 2 points are across from each other. That really should happen because of the symmetry of the parabola. If we look back at our parabola, notice the points that are across from each other. That's the symmetry around the line that goes through the vertex of 0, 0, which we call the axis of symmetry. So you can kind of catch some mistakes you sometimes make with graphing points when you recognize you have to have that symmetry. Then, all right, we've got these points to do. So let's say we've got our 2, 4. So what 2, 4, and it might be easier to do the reflection first this time since I don't have a lot of squares above. So it would reflect, say, to -4, and that -4 times 2 would take it down to -8, and then it counts up 5, 1, 2, 3, 4, 5, and it ends up here at 2, -3. Then we have our -2, 4, which basically does the same type of thing. It reflects, it stretches to -8, and then it moves up 5 right across from the previous point. And now, because these 2 points won't fit on our graph because we don't have enough squares, now we draw on our parabola. Make sure that you start over in this space, and make sure that you do it rounded at the top, not pointy. And make sure you end up in this space and put arrows on the end. So your parabola is U-shaped, remember, not V-shaped. So it's got to be rounded. And your end behavior, this is what I see some people do, and this is wrong. Some people go straight down. That's not what the parabola does. The parabola, remember, is going to head out to points at 3, what is -18 plus 5, -13, which doesn't fit on our graph. It's going to end up over here somewhere and over here somewhere. So it's heading towards those next points. So always make sure that you graph your end behavior in the spaces with those arrows. All right, that would finish this problem. Let's take a look at another one here. So here's the function that we are going to graph. So from this structure here, we have to realize that what we have, that this is our A, that the opposite of that +3 would be our H, because it's inside the parentheses and there's our quantity squared, and with nothing after our quantity squared, that tells us it's like having a +0 out here, and that would make K the 0. So our A value is 1/2. Because it is positive, there will be no reflection. The absolute value of A, the absolute value of a positive number, is still the positive number. And then compare it to 1. And 1/2 is less than 1, so that means we have a stretch, a vertical, sorry, did I say stretch? I meant compression. Sorry about that. It means we have a vertical compression. And our factor of that compression is 1/2. And then the opposite of the +3 gives us H. So H is -3, and H is about horizontal translation, so this will take us to the left. So for part A, I'm going to again write it out all nice and neat. I'm only going to write what we do have. So we have a vertical compression. Always include the factor here by a factor of 1/2. And we have a translation. Left 3 units, or you could say 3 units left. All right, so that completes part A. Again, for part B, our graph, it's important that we understand the points we're starting with. So until they start to stick in your head, it's a good idea, like I've been modeling, to write them down on the side somewhere where you have some space. So the x's again are the integers from -3 to +3. These are our key points of our parent function that we're going to graph. And then the y values that go with it are those numbers squared, which will all be positive, of course, because we're squaring. All right. So now what I'm looking at again, vertical compressions are going to make all of these y values smaller. And they're going to make them smaller by multiplying them by our factor of 1/2. So they're going to make them half as small. So it's like taking 9 times a half, which would be 9/2 or 4.5. And so we're going to be able to fit all of these points on this particular graph because the 9s are only going to be 4.5 units from the vertex. We are going to move to the left. So I just need to make sure I have 4.5, or basically 5 squares above. So I am just going to put my x-axis in the middle here. Or actually, maybe not. Maybe I'll move it down a little bit, just to make it easier to model the 9s. They'll be on our graph this way. Now, because I have a translation to the left, moving left 3, I might want to move my y-axis in the opposite direction a little bit. So I'm going to push my y-axis to the right a little bit over here. All right, so I'm going to put some numbers on here. That helps with accuracy. Always use a scale of 1 unit for these problems. Do not change your scale. That means each square, every direction is 1 unit. All right, so now what I'm going to do is, I like to start with my vertex. It does not really matter which point you start with as long as you keep track. So some people like to start, with the -3, 9, far left and work their way to the right. Some people like to start with the vertex and then move outwards, which is what I'm going to do, but it can be done either way. So 0, 0 is not affected, remember, by stretches, compressions, or stretches. Reflections, stretches, or compressions. I think I said compressions twice there. Reflections, stretches, compressions don't affect 0, 0 because it's like multiplying by 0. Anything times 0 is 0. But it is always affected by translations. So 0, 0 is going to move 3 to the left, and that is where our new vertex is going to be. Then we're looking at 1, 1, for example. So 1, 1, it's like taking this 1, this y value of 1, and multiplying it by 1/2. So it goes from here to half that distance. And then it moves to the left, 1, 2, 3, and ends up right there. Then we've got our -1, 1, which again would be multiplied by 1/2. And then it would move left 3, 1, 2, 3. So notice that they are across from each other like they should be. Then I've got 2, 4. So this distance of 4 is going to be multiplied by 1/2. Remember, multiplying by 1/2 is like dividing by 2. So just in case you're wondering, you should not be using a calculator here. All of this math you should be able to do without a calculator. So 4 times 1/2, or 4 divided by 2, is 2. So it's going to squish to, from going from 4 units above the x-axis to only 2, half of that. And then it's going to move left 3, 1, 2, 3, and ends up right there. And then we have our -2, 4, which compresses and moves left. So notice those 2 points are across from each other. Then we have our 3, 9. So now half of 9 would be 9/2, and 9 divided by 2 is 4.5, or 4.5. So the 3, 9 compresses to half that distance, which would be right there, and then it moves left 3, 1, 2, 3, and ends up right there on the y-axis. And then -3, 9 compresses and then moves left, 1, 2, 3. Notice they are across from each other. So now we've got all of our necessary key points. We've graphed all of them, which we could do, which was expected because we could. And now we're going to draw in our nice curved, rounded U shape, like so. Put arrows on the ends. Notice I'm in those spaces. So again, what I don't want to see is you drawing your end behavior going straight up. because it's not ever going to do that. It's always going to head outwards. All right, I do believe there's a practice problem here for you. Yeah, I will pause the video here and give this one a try. All right, let's take a look at what the graph should look like. So your transformations, hopefully you came up with a reflection across the x-axis or x-axis reflection, and that there's a translation to the right, 1 unit. So this is what your graph now looks at, and you should have all of these points on your graph. They're all perfectly reasonable to fit on that grid that you have been given. All right, moving on. All right, so now here is the function that we are graphing. So given this structure here, that 4/3, that would be our A parameter. The opposite of that -2 is going to be our H, and that -3 is our K. So our A is 4/3. So being positive, that means there's no reflection. The absolute value of A would be the absolute value of 4/3, which is still positive 4/3. And here what you have to realize, here's your number sense coming in. Developing number sense is super important as you move upwards in mathematics. 4/3 is an improper fraction. The numerator is larger than the denominator. All improper fractions are larger than 1. That's super important to realize. Now, if you know what it is as a mixed number, great, but as long as you know it's greater than 1, then you know that, okay, that means you have a stretch. So we've got this vertical stretch coming from this, and our factor of that stretch is going to be 4/3. I'm not going to use the mixed number for my factor because we don't multiply by mixed numbers, we multiply by their improper fraction form. Then our H value would be the opposite of that -2, which is +2. So that means we're going to go to the right those 2 units. And our K value would be -3, which means we're going to go down those 3 units. So now to complete part A, I'm going to write out what we have. So first we have a vertical stretch. And again, include by the factor of, or by a factor of, 4/3. And then I'm just going to put my 2 translations together. So I'm going to say translations, plural, of 2 units right and 3 units down. All right, so that finishes up our part A. So now again, moving to our graph here, I'm looking again at making sure that I realize what my key points are that I have to transform, and making sure that if I can graph them all on the graph that I do. So sometimes it is helpful. Sometimes you'll easily be able to tell whether, oops, that should be a 0. Squeeze that in there. Oh, just move that up. That'll work. So sometimes it's best to kind of do the math, at least in your head, or as I'm showing here on the paper. So what I want to know is, can I graph all of these, and where should I draw my axes so to make sure that if I can graph them all, that I can fit them on the graph. So what I like to do then is kind of do my math of my stretch factor to see what new number I'm going to get. So what's going to happen to these 9s, which are the largest y values we're expected to graph, is they're going to be multiplied by 4/3. And so when we multiply by 4/3, that gives us 36/3, because remember the 9 has a denominator of 1. And multiplying straight across gives us 36/3. And then that's actually 36 divided by 3 is 12. So that means that would become a 12. And we have 15 squares, remember, so that means we should be able to graph this just fine. Then it's going to move down 3. But we don't really have to do that math. All right, what we need to know is what's the distance between the vertex, which is going to stay at 0, because anything times 0 is 0, and this farthest point away, so it's 12 units. So that means that from where I put my vertex, I'm going to need 12 squares to make sure it all fits on the graph. Sometimes you're going to find that, oops, you didn't draw it in the right place. I have done it myself. And then, yes, you are expected to erase and go back and redraw it in a better place so that you can fit it all on the grid. So I'm looking here at what's going to happen to 0, 0. Now 0, 0 is also going to move down 3. So that means it's going to go down to -3. And the so I have to make sure that I have at least 3 squares below my x-axis. So now my vertex will be on this line. And then 12 units above that is where I'm going to have my highest points. So that'll work. We are moving to the right, so it might be a good idea to push our y-axis a little bit to the left, but may not absolutely be necessary. But I like to do that just in case. So now I am looking at graphing my points. So I'm going to start with my 0, 0. So 0, 0 again is not affected by the stretch, but it is affected by moving right and down. So it moves to the right 2 units and down 3 units, putting it here. Just going to throw in some numbers here for clarity. All right. Then 1, 1. Now 1, 1 is going to stretch, and it's going to stretch by that factor of 4/3. 1 times anything is that value, so 1 times 4/3 is 4/3. Here's where it's going to be important to know the mixed number that goes with this is 1 1/3. If you don't remember how to do that, remember all I'm doing is dividing 4 by 3. That goes in once, and then I'm taking my remainder over my divisor. And so that means that 1, 1 is going to stretch to 1 1/3 right there. And then it's going to translate. So it's going to translate to the right, 1, 2, and then move down 3, 1, 2, 3. I want to point something out here at this point. Notice that this line right here that goes through my vertex, this horizontal line, the distance from my new point, my 1, 1 point where it ends up to that line is 1 1/3. That is not a coincidence. Once you get the hang of it, you can actually use that relationship to graph more quickly. All right, so now my -1, -1. So it's going, or -1, 1 rather, it's going to stretch to the same 1 1/3 height. And then it's going to translate to the right, down 3. Notice it is now straight across from the other point that we did. Then I'm going to do my 2, 4. So my 2, 4, that 4 is going to be multiplied by 4/3. So multiplying straight across again would give us 16/3 because 4 has a denominator of 1. And 16/3 as a mixed number would be 5 1/3. So what that's telling me is that 2, 4, which starts here, stretches to 5 1/3, which is right there. And then it translates to the right and down 3 and ends up here at 4, 2 1/3. And then we've got our -2, 4. So it stretches to 5 1/3, translates to right, down 3, and ends up right there on the y-axis. All right, so now we are to our 3, 9 and our -3, 9. So we already know that we've done the multiplication. That gives us 12. So 3, 9, which is here, is going to stretch to 12 units. 9, 10, 11, 12. Don't worry, it's coming back down, remember, with our translations. So then it's going to move to right, 1, 2, and then down 3, 1, 2, 3. And it ends up here. Notice that this is the line where our vertex is, that the distance from this line up to that point is 12 units. That's what we're looking for, that final 12 units. And then we have our -3, 9, which stretches, translates right, and translates down, and ends up right across from the previous point. So now that's all of our key points. Now we're going to draw in our parabola. And again, we want to get our end behavior over in that space. This is not turning out to be my prettiest parabola. Let's try that. Oh. There we go, a little better. Rounded through the vertex, so it's a U, not a V. Get in that space over there. Put my arrows on the end to finish my graph. Definitely a little more wiggly than it's supposed to be. That did not make it any better. Those of you who are perfectionists will appreciate my struggle here. Okay, I like that a little better. All right, let's try practice. Pause the video here and try this problem, then come back when you're ready to compare the answer. All right, let's take a look at this answer. So hopefully these are the transformations you came up with. A vertical compression by a factor of 1/2, a translation left 4 units and up 2 units. And then all of your points, all 7 of them, should have been graphed as shown here. All right, that does finish up this lesson. I hope you have a wonderful day.